To determine the appropriate circuit breaker size for a solar inverter, several factors must be considered. These calculations are crucial for ensuring the safe and efficient operation of the solar power system and for complying with electrical codes. Firstly, let's examine the first sample system, which consists of 30 Canadian solar 285-watt solar panels arranged in 3 strings of 10 panels each, connected to a single SMA America SB 9240 volts inverter. The inverter's maximum output current is rated at 37.5 amps. To find the appropriate circuit breaker size, we need to look at the inverter's maximum output current, which is 37.5 amps. The National Electrical Code, or NEC, requires that overcurrent protection devices, such as circuit breakers, be sized no smaller than 125% of the continuous current. This is to account for sustained operation at or near the maximum current level, which could cause the breaker to trip prematurely if sized too close to the actual current. Therefore, we must multiply the inverter's maximum output current by 1.25. In this case, 37.5 amps multiplied by 1.25 equals 46.875 amps. This calculation gives us the minimum required ampacity for the circuit breaker. However, circuit breakers are available only in standard sizes. We need to select the next standard size circuit breaker that is equal to or greater than 46.875 amps. Common standard circuit breaker sizes include 15 amps, 20 amps, 25 amps, 30 amps, 35 amps, 40 amps, 45 amps, 50 amps, 60 amps, and so on. In this case, the next standard size above 46.875 amps is a 50 amp circuit breaker. Therefore, a 50 amp circuit breaker would be the appropriate size for the service panel in this sample system. Now, let's consider the second sample system, which consists of 27 Canadian solar 285-watt solar panels arranged in 3 strings of 9 panels each, connected to a single SMA America SB 8240 volts inverter. This inverter has a maximum output current of 30.4 amps. Following the same procedure as before, we must first multiply the inverter's maximum output current by 1.25 to account for continuous operation. 30.4 amps multiplied by 1.25 equals 38 amps. This value represents the minimum required ampacity for the circuit breaker. Again, we need to select the next standard size circuit breaker that is equal to or greater than 38 amps. Referring to the common standard circuit breaker sizes, the next size up from 38 amps is a 40 amp circuit breaker. Therefore, for the second sample system, a 40 amp circuit breaker would be the appropriate choice for the service panel. It is important to note that these calculations provide a general guideline for determining the appropriate circuit breaker size. However, several other factors can influence the final decision. These factors include the specific requirements of the inverter, the wiring methods used, the ambient temperature, and any applicable local electrical codes. The inverter manufacturer's documentation should always be consulted for specific recommendations regarding overcurrent protection. The documentation will typically specify the minimum and maximum allowable circuit breaker sizes, as well as any other relevant requirements. Wiring methods also play a crucial role in determining the appropriate circuit breaker size. The ampacity of the conductors used in the circuit must be equal to or greater than the rating of the circuit breaker. The National Electrical Code, in Article 310.15 and related tables, provides detailed information on conductor ampacity based on conductor size, insulation type, and installation method. It is essential to ensure that the conductors are adequately sized to handle the continuous current without overheating. Ambient temperature can also affect the ampacity of conductors. At higher temperatures, the ampacity of conductors decreases. The NEC provides correction factors to adjust conductor ampacity based on ambient temperature. These correction factors must be applied when the ambient temperature exceeds the value specified in the NEC tables. Local electrical codes may have additional requirements or restrictions that must be considered when sizing circuit breakers. It is essential to be familiar with the local codes and to comply with all applicable regulations. In summary, determining the appropriate circuit breaker size for a solar inverter involves several steps. Firstly, identify the inverter's maximum output current. Secondly, multiply the maximum output current by 1.25 to account for continuous operation. Thirdly, select the next standard size circuit breaker that is equal to or greater than the calculated value. Fourthly, consult the inverter manufacturer's documentation for specific recommendations. Fifthly, ensure that the conductors are adequately sized for the continuous current and ambient temperature. Sixthly, comply with all applicable local electrical codes. While these calculations provide a good starting point, it is always recommended to consult with a qualified electrician to determine the appropriate circuit breaker size for your specific solar system. A qualified electrician will have the expertise and experience to assess all relevant factors and ensure that the system is installed safely and in accordance with all applicable codes and regulations. For example, the calculation 37.5 amps times 1.25 equals 46.875 amps. Therefore, the next standard size circuit breaker rating is 50 amps. As for the second system, the calculation 30.4 amps times 1.25 equals 38 amps. Therefore, the next standard size circuit breaker rating is 40 amps. These are only examples, and consulting a qualified professional is always recommended. Remember that this information is for educational purposes and should not be considered a substitute for professional advice. Electrical work can be dangerous, and it is essential to take all necessary precautions to ensure your safety. Always to energize circuits before working on them, and use appropriate personal protective equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Let's delve a little deeper into some of the considerations that an electrician might take into account when selecting a circuit breaker for a solar inverter. One crucial aspect is the series rating of the equipment. The series rating refers to the maximum fault current that a circuit breaker can safely interrupt when it's used in combination with other overcurrent protective devices like fuses or other circuit breakers within the system. If the available fault current at the inverter's location exceeds the series rating of the circuit breaker, it could lead to catastrophic failure of the breaker during a fault condition, potentially causing significant damage or even a fire. The electrician will carefully analyze the potential fault current levels at the installation site and ensure that the selected circuit breaker has an adequate series rating in conjunction with any upstream protective devices. Another factor is the type of circuit breaker used. There are different types of circuit breakers available, each with its own characteristics and suitability for different applications. For instance, some circuit breakers are specifically designed for use in photovoltaic or PV systems and are labeled as such. These breakers are often designed to handle the unique characteristics of DC current and voltage found in PV systems, such as the potential for sustained arcing. An electrician would select a circuit breaker type that is appropriate for the specific application and certified for use in solar installations. Voltage rating is also very important and must be rated for at least the maximum voltage the system is likely to see. Furthermore, the electrician will consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the load end of the circuit is less than the voltage at the source end due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. The electrician will calculate the voltage drop in the circuit and select conductors that are large enough to minimize voltage drop to acceptable levels. This may necessitate using larger conductors than would otherwise be required based on ampacity considerations alone. In addition to these technical factors, the electrician will also consider the aesthetic aspects of the installation. The circuit breaker will typically be installed in a service panel or load center, which is often located in a visible area. The electrician will strive to select a circuit breaker that is aesthetically pleasing and blends in with the surrounding environment. This may involve choosing a circuit breaker with a specific color or finish, or selecting a service panel that is designed to be visually appealing. The electrician will also ensure that the circuit breaker is installed in a location that is easily accessible for maintenance and inspection. The NEC requires that circuit breakers be readily accessible and not obstructed by other equipment or materials. This is to ensure that the circuit breaker can be easily turned off in the event of an emergency. As a reminder, always consult with a qualified electrician for any electrical work. Electricity can be dangerous, and it is essential to take all necessary precautions to ensure your safety. An electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with all applicable codes and regulations.